Okay, so we're going to put everything together, combine transformations. So we'll look at questions where we're going to have, in some cases, all four parameters changing and what that looks like. So we'll sketch the graph of transformations by applying translations, reflections, and stretches, and then we'll also look at writing the equation of a function that has been transformed from y equals f at x. So whenever you have multiple transformations to do, you have to remember to put them in the correct order, okay? And basically it follows the same as our normal order of operations. Let's say you do your multiplying and dividing first, you're adding and subtracting second. So which means that you will do your stretching and reflecting first, and then do your shifting, your translation. So there's a couple things you can remember if you remember the acronym SRT, which says stretching and reflecting first, translation second. That might help you. The other way to look at it is that as long as you get y by itself, so you have everything on the other side, if you follow the order that the parameters appear in the equation, you're going to have your a and b first, right? Because we're going from y equals f at x to y equals a f bracket b bracket x minus h plus k. So the first two parameters that appear there are the a and the b. That's what does the stretching and reflecting. The last two parameters are h and k. That does your translating. So if you do the a and b first, that's your stretches and reflections. And then do your translations last, that's your h and k. So you have to do them in the right order. Now, you will see that if you're stretching horizontally and shifting vertically, then actually order doesn't matter. Or if you're reflecting vertically and shifting horizontally, again, the order actually won't matter. But just to be safe, we'll always do things in the same order. Stretching and reflecting first, translations second. So again, there's a summary about what all four parameters do there. So hopefully you kind of remember that by now, because you have to know it. You're going to be tested on it several times, not only in this course, but also on the diploma exam. Transformations comes, you're going to be seeing transformations in the first 8 chapters. We're going to be talking about transformations. So it is a fairly common theme in this course. So this first example, we're asked to describe the combination of transformations that must be applied to y equals f at x to obtain the transform function. We'll sketch the graph showing each step and also do a mapping notation. So we're going to start with that function, but notice there's no equation given. It's just y equals f at x. And we want to transform it to 3 times f at 2x. So we have two parameters there. The first one, the 3, that is the a value because it's in front of the f. So here we have an a value of 3 and a b value of positive 2. And that 2 is a p-value because it's in front of the x. Whatever happens to the x, same thing happens to the bx. In this case, it's in brackets after the f. So there's going to be two different transformations. First, an a value of 3 means that we will have a vertical stretch about the x-axis. By a factor of 3. And then a b value of 2 means a horizontal stretch. And the horizontal stretch is always about the y-axis. But remember, the stretch factor is always the reciprocal of b. So we're going to have a horizontal stretch by a factor of 1/2. So let's take all 1, 2, 3, 4 of those points on the original graph, and we'll systematically perform these transformations to each of those 4 points. So we've got the point 0, 0. We've got the point 1, 1, 4, 2, and 9, 3. If you have first an a value of positive 3, as we've written above, that means you're going to vertically stretch by a factor of 3. On a graph, vertical goes up and down, so it's the y values that go up and down. You're going to multiply all the y values by positive 3. So for that first point right now, it'll be invariant, because multiplying the y value of 0 times 3 doesn't change it. But the other y values will change. You're going to multiply each y value by 3. The x values are going to stay the same for this part. So there's our new points after multiplying each y value by positive 3. And I wrote 3 there when it should have been 6. So there we go. And then we have a b value of 2, which, as we wrote above, means a horizontal stretch by a factor of a half. So now all the x values will get multiplied by a half. The y values will stay the same from the previous points. Only the x values will change. And once again, 0 times a half stays 0. But then we're going to have 1 times a half, 4 times a half, and 9 times a half. And there's our new points. Multiplied each x value by a half. So now we can put these new points on there. We've got the point 0, 0. Okay? 1/2, 3. 2, 6. And 9/2, which is 4.5, 9. The original graph had a definite starting point and ending point, so our new one will as well. No arrows on the ends. There's our new graph. And our mapping notation, we multiplied all the x values by a half, we multiplied all the y values by 3. So there's our mapping notation. Okay? Now, this next one. Remember, the general form of our transform function is y equals AF. We've got the big square brackets with the b and the x minus h separated by brackets. Okay, the x minus h is in brackets after the b. This next equation is not in that form. Okay, this next equation will have a b parameter and an h parameter that we have to deal with. The b parameter is 3, but the h parameter is not -6. To get the proper h parameter, the equation must be written in the same form as what's above, meaning the b and the x minus h have to be separated by brackets. So to get that, what we do is we take out a common factor of 3, and that'll leave you with x plus 2, and now it's in the proper format to get the correct h value. B and x minus h must be separated by brackets. In the original equation, they weren't, so we need to do that by taking a common factor of 3 out, and now we have it in the right format to get the correct h value. We have a b value of 3, and our h value is -2. So b equals 3, h equals -2. So if we have a b value of 3, that gives us a horizontal stretch about the y-axis. Okay, so we have a horizontal stretch about the y-axis. Remember that the horizontal stretch factor is always the reciprocal of b. So we have a horizontal stretch by a factor of a third. And then the graph is going to shift 2 units left. So we'll do the same thing as we did before. We'll start with those same points. And we'll do all of our transformations to those points. The first one being when b is 3. As we said, that's going to cause a horizontal stretch by a factor of a third, which means all the x values, because horizontal goes left and right, and it's our x values that go left and right, all our x values will be multiplied by a third. So it won't change that first point, but the other points, the x values will change. We're going to multiply each x value by 1/3. 1/3 of 9 is 3. And then, if we go 2 to the left, because h is -2, now we're going to subtract 2 from all the x values. So now the first point will change, because when you subtract 2 from the 0, you'll get -2 as an x value. When you subtract 2 from a third, I will write 2 with a denominator of 3, which would be 6/3. So 1/3 take away 6/3 is -5/3. 4/3 take away 6/3 is -2/3. And 3 take away 2 gives us +1. So there's our new points. This graph will start at -2, 0. Our next point is -5/3, or -1 2/3, 1. -1 2/3, 1, approximately there. -2/3, 2, approximately there. And 1, 3, right there. So the original graph has a starting point and an ending point, so our new one will as well. There's no arrows on the ends. And our mapping notation, both of these transformations were on x. We took 1/3 of x, and then we subtracted 2. Our y values never changed. Okay? So we start with the same graph, and we're going to do these transformations. So for question A, we have an a value of 2 because a is in front of the f. And that minus 3 is a k value because it's outside the brackets. Remember, x minus h is inside brackets. H is hooked together to the x with a plus or a minus, so they both have to be inside the bracket. This minus 3 is outside the bracket. That makes it a k value of negative 3. So we have an a value of 2 and a k value of negative 3. Which means that we're going to have a vertical stretch about the x-axis, and that would be by a factor of 2. And because k is negative 3, we're going to have a vertical shift of 3 units down. What's your name? Blaney? Did you sign in, Blaney? Okay, thank you. All right, so again, we'll start with those same 4 points. 0, 0, 1, 1, 4, 2, 9, 3. And an a value of 2 means a vertical stretch by a factor of 2. Verticals up and down. And on a graph, it's the y values that go up and down. So we're going to multiply all the y values by 2. And then a k value of negative 3 means the graph is going to shift 3 units down. So now we will subtract 3 from the y values. So again, in this case, there will not be any invariant points. We're subtracting 3 from all the y values. So we've got the point 0, negative 3. Our next one is 1, negative 1. Our next one is 4, positive 1. And our last point is 9, 3. Again, this graph has a definite starting point and ending point, so we don't put arrows on the end. And our mapping notation, both of these parameters affected only the y values. We vertically stretched by 2 and went down 2. Our x values didn't change. Our y values are multiplied by 2 and then decreased by 3. Now for question B, once again, if we look at that equation, the b value is a half, but the h value is not 2, because b and x minus h have not been separated by brackets. So we need to do that by taking out a common factor of the b value, 1/2. And to get what's inside the brackets, you divide each term by a half. So negative 2 divided by a half is minus 4. Dividing by a half is the same as multiplying by the reciprocal, 2 over 1. So now we can see that the true h value is actually 4. And you need to do this step. If the b and the x minus h are not separated by brackets, you need to do that to get the correct h value. So we have a b value of 1/2 and an h value of 4. Remember, the value of h is always the opposite of what it appears to be. And so therefore we're going to have a horizontal stretch and remember the stretch factor is always the reciprocal of b, but it's horizontally stretched about the y-axis. And that would be by a factor of 2. The reciprocal of b gives you the horizontal stretch factor. And h is positive 4, which means it's going to shift 4 units to the right. The value of h is always the opposite of what it appears to be because the general equation is already in the format x minus h. So again, we'll start with those same 4 points. And our first parameter is a b value of 1/2, which again meant a horizontal stretch by a factor of 2. So all the x values get multiplied by 2. That first point will be invariant for now, but it won't be at the end. But for this step it will be because you're multiplying the 0 in the x position by 2. And the same thing with the rest of those points. Each x value gets multiplied by 2. And then we have an h value of 4, which means the graph will shift 4 to the right, or we will add 4 to the x values. That last one should have been a 3, not a 2. So I've got the point 4, 0. My next one is 6, 1. My next one is 12, 2. And my last one is 22, 3. So the curve would look something like that. And our mapping notation. Both of these were transformations on x. We multiplied all the x values by 2 and then added 4. None of the y values changed. Right, so all of these equations, the original equation was just in terms of f at x, and so all of our transformation statements involve the letter f and the variable x. On this next one, we're going to start with the graph of y equals x squared. So we're going to do all the transformations. We're also going to write the corresponding equation, as well do a mapping notation. But we'll start with the graph of y equals x squared, which we've done quite a bit of already. I'm sure some of you are graphing this in your sleep. You've seen it so many times. And this will have arrows on the end. Whenever you graph from an equation, unless you're told that there's some restrictions, the graph will continue on. So the first parameter we have is our a value, and our a value is -1/2. So we have a equaling -1/2. We have a b value of +2. Notice if you look at the equation, the b and the x minus h have been separated by brackets, so our h value is 4 and our k value is 1. So the fact that the a value is -1/2 does two different transformations. The first being, it doesn't matter what order you write them in, but we're going to have a reflection and a stretch. We will have a vertical stretch about the x-axis by a factor of 1/2. We're going to have a reflection around or about the x-axis. And those are the two things that an a value of -1/2 do. Two different transformations, one being a stretch, the other being a reflection. Then we have a b value of 2, which will give us a horizontal stretch. And again, horizontal stretches are about the y-axis. And that would be by a factor of 1/2. Remember, the horizontal stretch factor is always the reciprocal of b. And then the graph is going to shift or translate 4 units right and 1 unit up. And there's all the transformations that we're going to do. So if we write our points out, -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. The first parameter we had was our a value of -1/2. So that will vertically stretch it by a factor of 1/2. That means you multiply the y values by 1/2 and also reflect it over the x-axis, which we can do by multiplying the y values by -1. But we can do them simultaneously. We can do our stretching and reflecting simultaneously by multiplying all the y values by -1/2. So that's what we're doing here, multiplying all the y values by -1/2. So the point 0, 0 will be invariant for now. But the rest of the points will change when we multiply the y values by -1/2. Then we have a b value of 2, which causes a horizontal stretch by 1/2. So now we're going to multiply all of the x values by 1/2. So 0, 0 will be invariant for now. It's not going to stay that way. But for now it is. Multiplying all the x values by 1/2. And finally, we have an h value of 4 and a k value of 1. So I'm going to do both of these together. But let's start with all the x values. An h value of 4 means we're going to add 4 to all the x values. When you add 4 onto -1/2, I would write 4 as 8 halves. 8 divided by 2 is 4, but it'll have the same denominator as negative a half. So negative a half plus 8 halves would be 7 halves. 0 plus 4 is 4. 1 half plus 8 halves is 9 halves. And 1 plus 4 is 5. A k-value of 1 means the graph shifts up 1, or we're going to add 1 onto all the y values. Adding 1 onto negative 2 becomes negative 1. When you add 1 to negative a half, I would write that as 2 over 2, same denominator. Negative 1 over 2 plus 2 over 2 is positive 1 over 2. 0 plus 1 is 1. Negative 1 half. Negative 1 over 2 plus 2 over 2 again is positive 1 over 2. And negative 2 plus 1 is negative 1. So there's my new points. So again, we did our stretching and reflecting first, translations last. So I've got the point 3, negative 1. I've got the point 7 halves, which is 3.5 comma 1 half. 3.5 comma 1 half would be approximately there. I've got the point 4 comma 1. 9 halves, which is 4.5 comma 1 half. And finally 5 comma negative 1. So the orientation of this change, because it was reflected over the x-axis, is now going to go downwards instead of upwards. The shape of it changed because it's been stretched, and the position changed because it's been shifted. And there's our new graph. So to write our equation, whatever happens to the x will happen to the bx, and also whatever happens to the x happens to the x minus h. The x is squared, so the b bracket x minus h will need to be all squared as well. You're going to have negative 1 half as our a value. We have a b value of 2, an h value of 4, and again, whatever happens to the x happens to the b bracket x minus h, which in this case is all squared. So that would be our new equation. And our mapping notation. So the two parameters that affect the x are the two inner parameters, the x and the b and the h. So we horizontally stretched by a factor of a half, so all the x values are multiplied by half, and then shifted 4 to the right, so we'll add 4 to the x values. The y values are multiplied by negative a half, and then increased by 1. So there's our mapping notation. So once again, we'll start with x squared and do this transformation. So there's our original graph for y equals x squared. So if we look at our equation, first we have a value of negative 2. We have a b value of a half. Once again, if you look at the equation, b and x minus h are separated by brackets, so our h value is negative 8, and our k value would be negative 3. So an a value of negative 2 means that we're going to vertically stretch about the x-axis, by a factor of 2. The fact that A is negative, again, means two different transformations. You've got your stretch as well as a reflection. So we will have a reflection about the x-axis. A b value of a half means a horizontal stretch about the y-axis. But remember, the stretch factor is always the reciprocal of b. So that would be a stretch factor of 2. And then finally, the graph is going to shift 8 units left and 3 units down. So, start with those same 5 points. And an a value of -2. We can do both transformations simultaneously. We're going to vertically stretch by a factor of 2 and reflect over the x-axis, so we can do those by multiplying all the y values by -2. So 0, 0 will stay invariant for now, but it won't end up that way. Multiply all the y values by -2. A b value of a half means a horizontal stretch by 2. So all the x values now get multiplied by 2. And then finally, we have an h value of -8 and a k value of -3. So I'll do these simultaneously. Starting with the h values of -8, I'll have to subtract 8 from all the x values. And now that 0, 0 will now change. Subtracting 8 from all the x values and subtracting 3 from all the y values. So I'll put these points on our graph, the first being -12, -11. The next -10, -5. -8, -3. -6, -5. And -4, -11. Our new equation, remember, because the x was squared, the b and the bracket x minus h must be squared as well. And our mapping notation, again, those two inside parameters are the ones that affect our x's. They were horizontally stretched by a factor of 2, so the xi was multiplied by 2 and then decreased by 8. Y was multiplied by negative 2 and then decreased by 3. So there's our mapping notation. So now we want to write the equation of a transform function. We want to write the equation for g at x in the form y equals af bx minus h plus k. So when you look at these graphs, you should immediately notice two things, maybe three things. One, the orientation didn't change. Okay, they both have the cusp below the maximum points. If you want to say they're both opening upwards, that's true. So that means the graph has not been reflected over the x-axis. You could say that the original graph was reflected over the y-axis because the y-axis runs right through the center of it. It's symmetrical about the y-axis, so you could if you wanted to, but it's not necessary. But the important thing is that the heights of the two graphs have changed. So the original graph had a height of 4 units. The new graph has a height that goes from 2 up to 10, so the new graph has a height of 8 units. That means that it has been vertically stretched by a factor of 2. Because the height, or if you want to say the range if you want, are twice the values of the range of the original, the height. Also, you should notice is that the width of the two graphs are different, right? This first graph has a width from -4 to +4, which is 8 units, whereas the second graph, the width is much smaller. It's only 2 units, which means that it's been horizontally stretched. Horizontally stretched by a factor of 1/4, because the width of the new graph is 1/4 the width of the original. 2 is 1/4 of 8. Also, the graph has been shifted. The cusp moved. Instead of 0, 0, the new cusp is at -7, 2. So the graph also went to the left 7 units and up 2 units. So, before we write our equation, let's write all this out. Again, this graph has undergone a vertical stretch by a factor of 2. And remember, the vertical stretch is always about the x-axis. So a equals 2. We have a vertical stretch by a factor of 2. That means that a equals 2. Next, we said there's a horizontal stretch. And the horizontal stretch is always about the y-axis. And again, we said that that horizontal stretch factor is by 1/4 because the width of the new graph, which was 2 units, is 1/4 the width of the original graph of 8 units. 2 is 1/4 of 8. which means that our b value is 4. The b value and the horizontal stretch factor are always reciprocals of each other. The b value is the reciprocal of the horizontal stretch. The stretch is the reciprocal of the b value. And then lastly, the graph shifts 7 units left and 2 units up. So therefore, h is -7 and k is +2. The original function is in the form y equals f at x. Even though it is an absolute value function, they didn't give it to us in that form, so we need to write our new function in terms of f, not in terms of an absolute value function, because we weren't told that. And what the difference really is here is the original graph and the new graph have a definite starting point and ending point. There's no arrows on the tops of those graphs, which means they start and they stop. Otherwise, we could write it as an absolute value function. Because if you have an equation, unless you're told there's restrictions, it would mean that the graph goes on forever. But this one doesn't. So therefore, it's just y equals f at x. So g in terms of f, so you've got an a value of 2. You have a b value of 4, an h value of -7, which means you're going to have, instead of x minus h, when you let h equal -7, it'll become x plus 7, and a k value of +2. Remember, whatever happens to the x happens to the b in the x minus h, in this case in brackets after the f. So there's our new equation. And our mapping notation, again, it's those two inside parts that affect the x values. We horizontally stretched by a factor of 1/4, so x is multiplied by 1/4 and then decreased by 7. The two outside parameters will affect the vertical transformations. A vertical stretch by 2, multiply the y values by 2, and then add 2. I put in equals there when it should have been a plus. Right, so there's our mapping notation. Okay?
Excuse the interruption. First responders. Nita, Chloe, Alyssa, and John.
That only happens when you've done something wrong and you're going to get suspended. So we'll see you sometime. Okay. So we're going from f at x to g at x. So if you look at these, the shape actually has changed a little bit. And so we know that because you can see that there's points that are highlighted here, like this point here, that point there, and they would correspond to these 2 points down there. Obviously, the graph has been reflected over the x-axis because the first graph opens up, the second one opens down, so the orientation has changed. So we do know that a will be negative, but the numerical value of a would change as well, because if we look at the original graph, the height from the vertex to those 2 points is 1 unit there. On this graph, the height is 1, 2, 3 units. So not only has it been reflected over the x-axis, but also it's been vertically stretched by a factor of 3, because the height from the vertex to those first 2 points on graph number 1 is 1 unit, whereas the height from the vertex to those 2 points on the second graph is 3 units. So not only has it been vertically stretched by a factor of 3, it's also been reflected over the x-axis. The width of the points has changed as well. On the original graph, the width between those first two points is 2 units. But on the second graph, the width is 1, 2, 3, 4 units. So it's also been horizontally stretched from 2 units to 4 units. So it's going to be horizontally stretched by a factor of 2. And once again, the graph will have shifted to the right 3 units and down 4 units. So H and K will also need to be changed. So once again, if we write this out, as we've said, we have a vertical stretch about the x-axis by a factor of 3, because we went from a height or distance from the vertex to those 2 points. That distance went from 1 up to 3. So vertical stretch by a factor of 3 and a reflection about the x-axis. So all these things together mean that our A value is -3. The negative part will do the reflection, the 3 will do the stretch. Then we said that the graph was stretched horizontally. So horizontal stretch about the y-axis by a factor of 2, which means, remember, that our B value is a half. The horizontal stretch factor and the B value are always reciprocals of each other. And finally, the graph is going to shift. It's going to shift 3 units right and 4 units down, which means that our H value is 3, our K value is -4. So our equation, now again, the original equation is just f at x. Even though it looks like those points match the graph of y equals x squared, there are arrows at the end of the graph, which means it goes on forever. But we'll still write it in terms of f and not in terms of x squared, because the original equation is just y equals f at x. So g at x will equal, we have an A value of -3. We have a B value of a half. It goes 3 units right, so our H value is 3. And remember, whatever happens to the x happens to the B bracket x minus h, in this case in brackets after f. And our K value is -4. So there's our equation. And our mapping notation, again, the 2 inside parameters affect the x. We horizontally stretch by a factor of 2, which means the x values are multiplied by 2 and then increase them by 3 because it went 3 to the right. Our y values are multiplied by -3 and then decreased by 4. So there's the mapping notation. And just a bit more practice with mapping notations. Let's skip A and B and look at C. You want to get y by itself, which means in this case getting rid of the coefficient of a third, and you would do that by multiplying both sides by 3. Now you're multiplying everything on the right by 3. So the f and what's inside that big square bracket are multiplied by 3, which writing a 3 in front shows that, but also the plus 2 needs to be multiplied by the 3 as well. You're multiplying both sides by 3, which means both terms. Yeah. Oh, I don't know why I wrote. The answer is no, but I shouldn't have changed that. That's a 2. You see, this is all one term. So our 3 in front of it shows that you're multiplying everything there by 3. You don't distribute it out, just the 3 in front. Okay? You don't distribute it out. But the last term is the plus 2. That gets multiplied by the 3. All right, so now we can write our mapping notation. Remember, the two inside parameters are the ones that affect the x's. Also have to remember that the horizontal stretch factor is the reciprocal of b. Okay, the absolute value of b is 2, so the horizontal stretch factor will be a half. But because b is actually negative 2, you'd multiply all the x values by negative a half. And then decrease them by 2 because h is negative 2. Our y values are multiplied by 3 and then increased by 6. So there's that the mapping notation. Let's skip down to question E. So there's a series of things that we need to do here to get y by itself. I would start by first subtracting the 4 from both sides. As well, notice that b and x minus h are not separated by brackets. So we have to do that as well by taking out a common factor of negative 4 inside those brackets, which will leave us with x plus 2. And remember, we subtracted 4 from both sides as well. And then we will divide both sides by 2, which is the same as multiplying by a half. So both terms on the right need to be divided by 2 or multiplied by a half. So there's our final expression. The two inside parameters will affect the x. We have a b value of negative 4, which will reflect it over the y-axis and horizontally stretch by a quarter. All the x values get multiplied by negative a quarter and then decreased by 2. Our y values are multiplied by a half and also decreased by 2. So there's the mapping notation. Question G. I will move the 6 over as well. Take out a common factor of 5 to get the b and x minus h separated by brackets. And then I will divide both sides by negative 3, which is the same as multiplying by negative 1/3. When you divide negative 6 by negative 3, it becomes positive 2. So a b value of 5 means a horizontal stretch of a fifth. You're going to multiply all the x values by a fifth. An h value of negative 1 means you're going to subtract 1 from x values, and then all the y values will be multiplied by negative a third and increased by 2. And so there's our mapping notation. So on the next page, there's a summary of what we've learned. And then if you skip a page, there's an assignment 1.3 there for you to work on. I will post the solution to Google Classroom. I would strongly encourage you to go through this assignment, do all the questions, check your answers on Google Classroom, make sure you're on track, because you guys are writing a quiz on Monday on this stuff. Okay? It's a short quiz, maybe 20 minutes. We'll do a lesson first, and then you guys will write the quiz. Okay? But spend some time getting ready. Also, if you haven't handed in that assignment from a couple days ago, it's got to get handed in on the filing cabinet. If you did hand it in, it's marked, and you can pick it up out of that basket over there. Go through it. If you did things wrong and you're not sure why, come and see me and I'll explain to you what you did wrong. But if you haven't got that handed in, it needs to get handed in. Okay? All right.